In this proof, I'm given two pieces of information. First, I'm told that M is the midpoint of AC. I'm also told that M is the midpoint of DB. With two midpoints, I'm going to get two pairs of congruent segments, and that's going to have me well on the way to having a method of showing these two triangles congruent to each other. So, if M is the midpoint of AC, it tells me that AM is congruent to MC. And I need to add that to my proof. If a point is a midpoint, then it divides a segment into two congruent segments. Second piece of information, another midpoint. So, I need to show that DM is congruent to MB. Same reason. DM congruent to MB. And since it's the same reason, I'll just put quotes here, repeating the same reason as before. At this point, I have two pairs of congruent sides with my two triangles. And if you look at my diagram, there's one other key thing that I can pull here. I know that the two vertical angles are going to be congruent. So I can mark those. In this case, that is angle AMD congruent to angle CMB. And the reason being, if angles are vertical angles, then they are congruent. At this point, I now have three different pairs of congruent parts marked on my triangles. I should be able to prove my triangle is congruent. So if we go back and look, I have a pair of sides, I have another pair of sides, I have a pair of angles. I do want to go to the diagram, make sure I have the correct order based on moving around the perimeter of the diagram. You'll notice I have a side, followed by an angle, followed by a side. So side, angle, side congruence here. I now know that triangle AMD is congruent to triangle CMB. And we said the rule there was the side, angle, side rule. Now I'm going to take a look at a second version of this proof. So continue watching the video and you'll see a slight variation on this with an extended concept. You'll notice I've left out most of the previous proof, the main reason being that I've only changed one thing about the proof. Instead of proving the triangles congruent, I now want to prove segment AD congruent to segment BC. The important thing here to realize is the instant that I've proved the two triangles congruent, I know that any of their corresponding parts are going to be congruent. And that applies in this case to segment AD and BC. So in general, when you're given a pair of triangles that can be proved congruent, use that information to show other parts congruent if you're asked to show parts congruent. So, only one additional step, relatively simple. I've already proved my triangle is congruent, so I know that segment AD is congruent to segment BC. And the reason, very simple. If triangles are congruent, then their corresponding parts are congruent. And I've finished my proof. This proof gives me quite a bit of information at the start. I'm told that angle QVT is congruent to angle RVU. QVT is this angle right here. RVU is the angle that overlaps that. Keep in mind that overlap is really important visually, should give us a chance to show some angles congruent in a couple of minutes. Angle Q is congruent to angle U, so I mark both of those congruent. QV is congruent to UV. I'm also told that R and T are midpoints. At the end, I always want to take a look at what I'm trying to prove before I start my proof. And you can see in this case, QS congruent to SU. Interestingly, those are segments up here at the top of the diagram. They don't seem to be really all that involved in the problem, but we've got to find a way to involve those somehow. You'll notice that the midpoints here, R and T, do seem to have something to do with the process. My line of thought in these problems is relatively simple. When I see a lot of congruent markings on triangles, I always ask myself, is there a way to prove those triangles congruent? And are there any parts of those triangles that are involved with what I'm trying to prove congruent in the end? And if you take a look here, you can see that if I can prove these triangles congruent, I can show that QR and UT are congruent to each other, which gives me parts of the segment that I'm trying to prove congruent, or actually parts of the two segments that I'm trying to prove congruent. So I'm going to follow with that idea. Number one, these two triangles are really close to being congruent already. The only thing I need to do is to show that these two base smaller angles are congruent to each other. You'll notice there's a shared angle in the middle. If I subtract that same angle from those two overlapping congruent angles, I'm left just with the outer angles. So I'm going to go ahead and mark these two bottom angles congruent to each other. Of course, that's by the subtraction property. So that's angle QVR congruent to angle TVU. And that is by the subtraction property. Keep in mind, I have to have congruent angles at the start to be able to do that, but I was given those congruent angles. Now, if I take a look back, I've already proved my two triangles congruent. I have an angle-side-angle relationship here. So let me go ahead and state that those two triangles are congruent. Triangle QRV is congruent to, make sure that your congruent statement matches. I said QRV. I need the corresponding parts to match up. That's going to be UTV. And that is by the angle-side-angle rule. Always a good idea to go back and check and see, do you have all the congruent statements here? And you can see that I have a pair of angles here. I have QV and UV, a pair of sides, and I have the angles for Q and U. So you can see that I do, in fact, have those congruent statements there. Now, unfortunately, QS and SU, which are the two segments I'm trying to prove congruent, are not segments of the triangles that I proved congruent. However, there are parts of those triangles that are congruent. I can at least show that QR has the same length as UT. So QR is congruent to UT. A lot of times you just have to show what you can show, and a lot of times you may be able to take a step beyond that and come up with what you're actually trying to prove. So in this case, these are coming from the congruent triangles. I've proved these two triangles congruent, so I know that their corresponding parts are congruent. If triangles are congruent, then their corresponding parts are congruent. And I'm almost done. Go back to the given. There's a given piece of information that I haven't used yet. It's the fact that R and T are midpoints. Remember, when you have double bisectors, double midpoints, double trisectors, if you have the same thing being done to two different congruent segments, you're going to get two congruent segments. And in this case, both of them are being divided in half. So QR and UT are congruent to each other. If the halves are congruent, I know that the wholes are congruent. I'm going from smaller segments to larger segments. I'm doubling those segments. That's going to be an example of the multiplication property. So I am done. After I make that statement, QS is going to be congruent to SU. If the halves are congruent, and these both have midpoints, I know that the wholes are going to be congruent. I'm doubling those segments. That's just an example of multiplication property. This proof has a lot of given information, and I want to look over it carefully before I get started. I'm going to mark my diagram. I think it'll help me visualize what's happening here. First of all, angle MDE is congruent to angle NED, so we have those there. Segment MD is congruent to segment NE. Segment AE is congruent to segment DC. So there's two overlapping segments there. And notice I have two midpoints. M and N are both midpoints. And if you look at the end, it doesn't ask me to prove the triangles are congruent. It actually asks me to prove that segment AB, this entire segment here, is congruent to segment BC. The only thing that I can see here that's going to allow me to get congruent parts is proving these two base triangles congruent. It's always a good strategy if you see congruent triangles, or if you see triangles that you suspect might be congruent, to make an attempt to prove them congruent, because if you can show that their corresponding parts are congruent. Maybe you can apply that to whatever you're trying to prove. So let's see how that works in this case. First of all, if I'm going to prove these triangles congruent, I need to prove some angles on the inside of the triangles congruent. Notice if these outer angles are congruent, the inner angles should be congruent. I'm going to subtract those outer angles from the straight angles to get congruent inner angles. So a little bit's going on here. I need to state that I have straight angles here. So I'm going to state that angle ADE and angle DEC are straight angles. And that's assumed from the diagram. You can also show that these are supplements of congruent angles and that these outer angles are congruent. I'm going to use the subtraction property. Remember what the subtraction property says. It says if congruent angles are subtracted from congruent angles, the differences are congruent. So I have to have congruent angles in the first place. I'm going to have to say that these straight angles are congruent. So angle ADE is congruent to angle DEC if angles are straight angles, then they are congruent. And now I can use the subtraction property. I'm going to subtract those congruent red angles from the congruent straight angles. And I'm going to show that angle MDA is congruent to angle NEC. And that is by the subtraction property. You'll notice that my two triangles are nearly congruent now. I will mark those two congruent angles here. I've got a pair of sides and a pair of angles in the two triangles. You'll notice I also have overlapping segments here. I need to show that AD is congruent to EC. And that's just a simple subtraction property. So second subtraction property. And that's going to give me this segment here congruent to this segment here. At this point, you can see my two triangles are going to be congruent by side, angle, side. So triangle, I'll call this MAD, is congruent to triangle NCE. Got to match up my corresponding parts by side, angle, side. And you should always go back and check your congruent statements. Notice here that I have AD congruent to EC, that's a pair of sides. I have MDA congruent to NEC, that's a pair of angles. And I also have, in the original given, MD congruent to NE, and that's a pair of sides. So always make that check. You want to make sure that you have all of your congruent statements there. Now, these two triangles have parts that make up AB and BC. Not the entire thing, but parts. You can see these two segments here are parts of those triangles. So I'm going to state that AM is congruent to CN. And of course, that's just because if triangles are congruent, then their corresponding parts are congruent. And I'm one step away from being done. If you look at the diagram, you'll notice that I have shown this segment congruent to that segment. I'm trying to show the whole segments, AB and BC, congruent to each other. Notice the important given information up here, double midpoints. If I have double midpoints, that means I have halves that are congruent. If I take those halves and I double those halves, I get wholes that are congruent. Doubling is multiplication. Multiplication property states that if these halves are congruent, the two wholes are congruent. And that is where I'm going to be able to finish my proof. So, AB is going to be congruent to BC by the multiplication property. And I am done.